New research indicates that Earth may have had its water since the beginning. Bacteria has survived on the outside of the space station for 3 years. Now fears grow over contamination of other worlds and our own. And one of the first fast radio bursts to be discovered turns back on right on cue. These are the stories we're following on Tuesday, September 1, 2020. I'm Matt Miller at Trekzone HQ. This is Talkin Science.
With the latest science and space news 5 days a week across Apple Podcasts, Spotify, Google Podcasts and YouTube. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
And it is a very happy Talkin Science Wednesday to Dr. Brad Tucker.
How's it going?
Really good, my friend, really good. How are you in the nation's capital this fine week?
Look, it's a bit warmer, actually, surprisingly, here in Canberra, which is always good. We've had some nice clear nights and beautiful skies. It was great to go and see Jupiter and Saturn and the Moon over the weekend, so it's been a real treat.
It's finally warming up and summer's coming back around again, and hopefully people don't remember the last summer too vividly.
Yeah, look, we're happy with just like a normal summer.
And of course, everyone can find you on social media at btucker22 on Twitter and Dr. Brad Tucker on Facebook. I'm on Twitter at Mirrormat86, and of course, Trekzone is all over social media as well. Just search for Trekzone, like, follow, and subscribe, and do all that good stuff so you never miss a moment from Trekzone, now podcasting 5 days a week. Brad, let's kick off the show.
Talking Science headlines.
And into our headlines, Brad. First up this week, Launchapalooza, 5 rockets in 4 days.
Yeah, we talked about a couple of weeks ago when there was these 3 rockets over a 24-hour period, and then space said, hold on, we could do better. With SpaceX and Rocket Labs and ULA and a whole bunch of other things, there's a few weather delays as always in there. But we saw, just this huge growth, and again, and how many rockets were taking place. And I think this just goes to show how quickly things are changing, how quickly things are moving, and how fast the industry is growing. And, it's just going to be becoming this kind of, I think, recurrent story where everyone just tops how many rockets we can launch in a period.
Well, we had a spy satellite, we had a SAOCOM 1B satellite, we had SpaceX with some more Starlink satellites. Astra, a California-based startup, rounded out the launch party on Sunday night, American time. So, great time to be alive if you love rocket launches.
That's exactly right.
And their other headline, now this one's really cool. We talked about it a couple of weeks ago, and the first results are in for satellite Selfie as part of National Science Week. And there's a Joey in a pouch.
That's right. So, I'm still processing the data. We're doing some final polishing and that sort of thing. So we've been starting to trickle out a few of the images before we kind of do our big release later next week. There was a great one where we saw this little Joey in a pouch. ACT Parks a couple of years ago did some planting, so they kind of made this natural wallaby. So a couple of people made the addition of adding the Joey into the pouch. You can see the head and the ears sticking out of the pouch there. So it's a really cool thing. And, it's exactly what we wanted to see for satellite Selfie. So there's lots of great ones out there, and the images will only get better and cooler from here.
Talking Science, Stories of the Week.
And Brad, let's kick off our Stories of the Week with a Kevin Costner film. This is exactly my first thought when you sent me this headline. It's all about Earth's water, and a new study is suggesting that it may not have come from meteorites as first thought.
Look, comparing anything to Waterworld is a bit harsh, don't you say? But yes, this has always been a big question. Where did Earth's water come from? It's something that we've wanted to know, because obviously it's key to understanding when, how, where, why life formed here on Earth, how unique or rare it is to have water on an inner rocky planet and in a solar system, and all these different reasons, because of this connection with life. And it's always been thought, or at least the leading theory has been that meteors or comets, even asteroids, something from the outer edge of the solar system crashed on the Earth, brought that water and gave it to us here. But a new study has shown that may not be true, and maybe it's been lingering around the inner solar system since the birth of Earth.
And the biggest reason for that theory is the fact of Earth's creation. It was, formed by the spinning of the rocks during the very beginning of the solar system. I guess naturally the sort of thought was, well, rocks and water don't really mix, so rocks first, water later.
That's right. That it probably, somehow came with it from later, because right, it was this whole hot, molten, rocky core. And when we see the outer system, the gas giants, the moons, those sorts of things, we see that they're rich in ice. We understand, well, we have a rough understanding of how, what we get, the frost line freezes, so things get colder on the edges of the solar system. But it appears a certain type of chondrite, a certain type of meteorite that is in the inner solar system was super rich in hydrogen. Now, obviously, water is H2O. So if you have hydrogen and that mixes with oxygen, bada bing, bada boom, you got water. and so it just shows that maybe those ingredients were just here from the beginning. Yeah, maybe it took time to form or whatever the case may be, but they were here, which would be a big important clue into what's understanding for our understanding for planetary formation.
This research, spearheaded by cosmochemist Laurette Piani, and I hope I'm doing that name justice, from the University de Lorraine, was looking at 13 rare meteorites and is arguing that the ingredients to form water were bound up in these chondrites, as you say.
And this is the important thing. It's finding these objects that were clues, or we know unique to the inner solar system, because that's the key, what was in the inner solar system, and then those things that were the ingredients for water. And both of those in this case appear to be true. Now, it's not saying that all of the water came or was already here. I think they estimated in the paper that maybe there was about 5 to 10% that was still needed to come from elsewhere, which people kind of can accept, right? There's multiple processes that happen. But the fact that it's showing that, hey, maybe the Earth or the inner solar system wasn't just this dry, barren place, that is not the case.
And this is very interesting. It's hard for someone like me who doesn't have the science background or the astrophysical background to imagine this, but it is a chemical reaction that creates water. And you said it there in the start of this story. You have hydrogen, you have oxygen, you have water. It's the binding of those molecules together that forms the liquid that is so needed for our life. You don't need to find the physical water. You just need to find those elements of water. And as you say, bada bing, bada boom, you've got life on planet Earth.
That's right. And it's kind of the reverse of what people are talking about doing in the moon. We see a lot of ice and we see a lot of water or water ice on the moon. We can then convert that ice into hydrogen and oxygen, so we can use it to create rocket fuel and air to breathe. So it's really the reverse process there that we're talking about for future space exploration. So, it just goes to show how important it's not just about the physics or studying the stars or planets. It's understanding the other processes that all come together and work together, the chemistry, geology, biology, and those sorts of things. And this is a great case of it.
And we talk about the hydrogen being found in these chondrites, forgetting the other important ingredient, the oxygen. And studies of the mantle, rocks in the mantle, have discovered rich oxygen deposits.
If you have that hydrogen from at least hanging around, and by seeing evidence that the Earth was fairly rich, or at least had a lot of oxygen in it, you have those ingredients. And again, it seems simple. It's obviously a tad more complicated than that. But that's the principle. That's the guiding bounds of what we need to create water. You don't just need to have this big ocean. And I think this starts to apply not just for Earth, but starting to understand all of the inner solar system, Venus and Mars as well.
And it can change up the way that we're studying these planets, looking for ice and looking for water oceans, as we have done on Mars and a few other moons out there in the outer solar system. Could now start looking for signs of hydrogen and oxygen.
That's right. We don't necessarily just need to say, hey, is there water or ice on this atmosphere or this place? Is there hydrogen? Is there oxygen? If we could detect that, yeah, there could be water, or at least something resembling water on that planet. So again, it can change our strategies for finding planets around other stars.
Brad, next up this week, spacefaring bacteria. As if 2020 wasn't scary enough, now we've discovered, I think we had an inkling that bacteria can survive in space, but now it's been confirmed after a culture spent 3 years on the outside of the space station.
Yeah, look, this is something people have been toying around and we've seen evidence for. And as we talked about a couple of months ago, NASA's issued new directives to prevent this contamination to places. But this is kind of the study that goes out and just shows pretty clearly that, yes, there are certain types of bacteria that can survive in the vacuum of space. And if it can survive in these harsh conditions, that means it can hitch a ride to the moon, it can hitch a ride to Mars, the vice versa. And that could be a big problem in terms of contaminating other worlds or contaminating our own.
It's long been a concern, and there's been clean rooms around for decades trying to stave off all of these earthbound contaminants, and as you say, vice versa, when we've had moon rocks return and other sample return missions as well. I guess this just sort of puts everything into perspective now and stiffens everyone's backs up and sort of going, okay, we really have to do this.
That's right. We really have to be on the ball. This is not an abstract threat. This isn't this random idea. This isn't us being overly concerned unnecessarily. This is a real problem that we have to address as we send these missions to Mars and moons of Jupiter and Saturn, and we bring asteroid samples back and all these sorts of things. There is this real possibility, and it could spell disaster for our planet. It could spell disaster for another object. The last thing we want is to contaminate a place. We don't want to, we want to go look for life in another place. We don't want to say, hey, we found life, but it just turns out we put it there.
Or vice versa. We found life and we kind of killed it.
Yeah, well, that too. Or we just have another outbreak on Earth, but this time from something from space. That would
we saw what a bat can do.
Yeah, exactly.
Well, it is ultra concerning, but it's all part of human understanding of space, and these are the risks that come with this sort of thing, and it's all about mitigating these risks, understanding them, mitigating them, and working with them to make them not as big of a deal.
That's right. I mean, this is why we do these things, is to understand the risks, to understand the science, to understand any potential problems. So we have better knowledge. And again, it just goes to show that, in all this great thing of space, microbiology here doing a really important discovery to guide our future space travel. Very important. And if we don't know these things, we don't know these things. And, that sounds simple, but we need to understand all of the issues with our space travels in order to do it safe and properly and ethically.
And we should credit, of course, Dr. Yamagishi and Japanese science team who put this culture on the outside of the space station and told it to sit there for a few years and see what happens. Hopefully the bacteria doesn't become self-aware and get angry about being left outside the space station.
Hopefully not. Hopefully it doesn't have a grudge, but I wouldn't be surprised.
2020.
2020, that's right. 2020. That's the only need to say.
It is incredible, too, that they've been studying this for 3 years. Researchers estimate that something thicker than 0.5 millimeters would have survived between 15 and 45 years on the space station. It's an incredible thought. Something so thin can survive so long.
Space is harsh, right? The vacuum of space, there's no air, the extreme temperatures, the pressures, the radiation, everything. It's hard to imagine anything surviving that. And this isn't, some specially designed extreme type of life. Though some could argue now it probably is. This is just a family of bacteria. And that is the surprising thing about it.
I'm just reading this press release issued from the team, and words like panspermia crop up. We're one step closer to proving that that's possible. There's some big words being thrown around in there, Brad. Should there be any major cause for concern?
No, I mean, when we're talking about, panspermia, the idea, again, is going back to this water thing. How did life originate on Earth? This gives a bit more support that, yes, bacteria or the ingredients for life could hitch a ride on something and survive in space. That's always been one of these debates. Is it just the ingredients that hitched a ride, crashed here on Earth, and triggered the processes? Did we start here already without something crashing? Or could an actual life form like this hitch a ride, come through space and crash here? So, it goes back to this big origin of life question as well. So a really important study.
And there was that Israeli lunar lander as well that left some tardigrades behind on the moon. So this is the sort of, these are the directives that we're trying to get into place and get everyone on par with so that we avoid these sort of contaminations. Tardigrades are a little bit bigger than bacteria.
That's exactly right. We if this can survive, other things can survive.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
Alrighty, Brad. Well, wrapping up our week in science and space news, a mysterious radio burst from space has woken up, and turns out one of the predictions was right.
Woke up right on cue. So, we've talked a lot about fast radio bursts, these mysterious radio bursts from space, which have been quite interesting and believed to be potentially involving some sort of black hole or binary system, two objects orbiting around each other. And that there's been what we've called the single fast radio bursts, these one-off bursts of radio light, and the repeating ones. And a studied one that was detected to repeated, they made a prediction that it was turning on and off at a very regular intervals, and that if the cycle held, it would turn on, continue the cycle and turn on at a very specific point. And lo and behold, it turned on exactly as it predicted.
The incredible thing with FRBs is that Parkes first discovered them in 2007. Since then, more than 100 have been identified. But one of the first discovered, FRB 121102, is the first one to have been localized and is attracting attention because, as we say there, it is repeating. And we have that cycle of between 156 and 161 days, then a 90-day sleep, and then it repeats again.
Because this one has been repeated multiple times, they've been able to, keep following it and observing it, and you said pinpoint the location. And so, of course, if they thought it was repeating, they were going to, point the telescopes at it and see, lo and behold, does it turn on as they think? I think that's kind of the exciting thing, is that there's still a long way to go in understanding these objects, but there's a big step in the right direction, at least in some of them, these repeating bursts, that there is a bit of understanding in the predictions of what's happening. And this can help us inform the physics and science behind it.
And when we're talking about these fast radio bursts, I think it's important to remember the expert team who are listening to the universe are picking these things up. They're only lasting about a millisecond.
They really are just these short bursts in space. So, it's not like they're just staring at this thing that is just bright for hours or days or months. It is these millisecond pulses. So you have to be your observations ready. You have to be prepared. You have to be looking at it, in the right spot. All these things. You have to have the weather on your side, technical things. Everything has to go right. And as you said, the cycle is quite long. So it takes a while to actually get to that point in order for this all to work. So it's great that they did.
And while they last just a few milliseconds, they generate as much energy as our sun does in 10 years. Some galactic scale going on.
And even though it's in the radio, it's very energetic. It's very powerful. And so obviously we want to understand what's going on. How are these things created? What's the source of these things? So this is a good step in the right direction.
Now, there are some estimates saying that there's 2,000 fast radio bursts occurring daily. So far, in 13 years, we've only discovered about 100 of them. But given what we just talked about, that's probably to be expected.
Yeah, that's right. It's a big sky. They're hard to find. So it sometimes can be quite tricky to track them down. So this is kind of why this repeating one is quite excited, is to be able to see something quite regularly and get more data on it, because that's the name of the game here.
And it was the National Astronomy Observatory of China that has backed up the evidence of FRB 121102. They've spotted it being active in this August this year, 2020.
Yeah, that's right. It was this thing that it was kind of known that it was going to turn on, so lots of people were ready to point their telescopes at it. And so, there's, by looking at different frequencies, as he said, more telescopes observing the same thing, it shows that these things are what we kind of think, or at least a step in that right direction. So it's a really exciting thing, and they're getting a little bit less mysterious. Still pretty mysterious, but a little bit less.
Fantastic, Brad. Well, it's fun to pick apart the stories of the week with you in Science and Space News, and we're going to do it again next week on another edition of Talkin' Science. We'll catch you then.
See ya.